Hi guys, welcome to the session. Hello Anil, hi Janvi, welcome to the class. So I'm Shivam, as you already know. I've taken a lot of sessions with you guys. Today we'll be talking about vector algebra. In fact, we'll take up two sessions on vectors. In the first session, which is the today's session, we'll talk about your scalar product and vector product. So we'll primarily talk about their properties and stuff related to it. In the next class, we'll figure out vector triple product and scalar triple product, the questions based on that. So a very warm welcome to all of you. Before getting started, let's wait for some more people to join and then we're gonna get started. So if you are in, please just post a little bit hi. Hello Ahir. Welcome to the session. All right. Fine enough. Most of us are here, so let's get started. So see, if I talk about the importance of vector and 3D, Aman. If I talk about the importance as an importance in terms of the number of questions which you're going to get in JEE Mains or JEE Advanced, what sort of questions or how many questions will you be able to get? So in JEE Mains, if I talk about just vectors, you can expect one or two questions in JEE Main, right? And if I talk about advanced, in advanced, you can also expect one or two questions, most likely one question on vector. In year 2018, we got two questions from vector algebra, which was again a good thing because vector is an easy topic to deal with. Similarly, if I talk about 3D, which is also the plan to be discussed in some time, so you can get two questions. Mostly you get two questions over here and two questions over here. In JEE Mains, you can have two questions. At least you will have one question, but at the max, you can have two questions, or maybe you can have in JEE Mains 3 questions on 3D. And in JEE Advanced, you most likely have two questions. So this is what the overall idea of the number of questions in vector and 3D is in terms of JEE Main and Advanced. So this in totality creates approximately three to four questions over here and approximately 3 to 4 questions in JEE Advanced. Hence, this turns out to be a handsome amount of questions. So the the most important bit over here is that the chapter is important as well as easy. So the questions which is given to you, if you are able to think about those questions even slightly, you will be able to get down to the answers. We'll see it with the help of few questions. Before moving on to questions, let me revise few things in scalar product, which is also called as the dot product. So if I talk about the dot product, most of you know what is a dot product. So for instance, if I'm saying A dot B, the formula to calculate A dot B is A B cos theta, where theta is the angle between these two vectors, which is a very simple formula which most of us know. From here, we can also get one thing: when theta is equal to 90 degree, in that case, A and B are perpendicular vectors, which implies A dot B must be equal to 0. So this is also a very important result as well as a very easy result, which everyone remembers. On top of it, you must also remember, or you must also know about the projection of vector A on vector B. What do we mean by that? Projection of vector A on B. Most of you would have been aware of this as well. If I'm talking about projection of A on B, basically what do I mean by that? If this is vector A and this is vector B, hi Hitansh, this is vector A and this is vector B, the projection bit will be, so I can sort of assume that there is a light bulb over here, a light bulb over here, right, which is glowing, and the shadow is being formed just below vector A. So a light bulb, I should place a bulb like this. So a light bulb that glows, and the projection comes up over here. So this projection is A dot B cap. What is B cap? B cap is the unit vector. B cap is what? It is the unit vector of B. So this is how we calculate the projection. Now we already know that it is a scalar quantity. Scalar quantity implies what? It is just a number. So this bit is just a number. So it is the length of this pink line, which we can see over here. Length of this pink line. Very simple to understand. So this is called as the projection of vector A on vector B. So we'll write it as A dot B cap. Now, in the same task, if in this on the same lines, if I tell you, or if I ask, what is the projection vector of A on B? So what will that be? So you'll say basically we already know the magnitude of that vector. We need to give it a direction. The direction is being given by the unit vector. So we usually write it as this is the projection, a number multiplied by its unit vector. So this is the projection vector of A on B. One more kind of a little important thing over here is, for instance, if I ask, this is not told many a times, but for instance, if I ask that what is the projection vector of A perpendicular to B, right? So if I want to find out the projection vector of A perpendicular to vector B, what will be doing on that? When you will have introduction to what? Fragile. Okay. Hi Aditi. So see over here, projection vector of A perpendicular to vector B. What do I mean by that? If this is vector B, this is vector A over here, this is vector A, I would want to have, can anyone suggest what this perpendicular vector be? Is perpendicular vector. So I'm basically referring to what this vector C would be. So let's say this is vector C. What will this be? So over here, the perpendicular vector, the projection of vector A perpendicular to B will be just this bit. To be more clear on this or precise on this. So this is what we are referring to. So over here, a very easy way to think about it is, no, see, it's not perpendicular to the plane, hence it will not be A cross B. It is not perpendicular to the plane. So we say that this is the component, which is the X component to it. We are talking about the Y component over here. So this component over here is, if I talk about the vector form, this is the vector in the given direction. I hope all of us can understand this very easily, that vector A is nothing but the sum of vector C, isn't it, and the given vector B. What do I mean by this? That this is basically equal to the summation of these two, right? By simple parallelogram law of addition, we know this plus this will give me the diagonal. So from here we can calculate C very easily. Vector C will basically be equal to vector A minus this bit. So remember these things. One last thing which I would like all of you to remember over here in terms of dot product is, it's not regarding dot product, but it's regarding the addition of vectors. So if I talk about vector along angle bisector of vector A and B, I've written it in shorthand. So however, I hope everyone understands, if I'm saying this is vector A and this is vector B, this is vector B and this is vector A, I'm talking about the vector along its angle bisector. So can anyone tell me what that angle bisector is? This, if you see, what we do, we again take a simple symmetry or simple geometry bit. What do we say? Choose a different color, maybe blue. So over here, what do we say? We figure out the unit vector along this line, and we figure out the unit vector of A. So we'll say that this is the unit vector. If these are unit vectors, the length of these two will exactly be the same, right? Hence, this will act as a rhombus or a parallelogram to that regards, right? So this will act as a parallelogram, or it will act as a uh, rhombus, because all the sides are equal in length. A is equal to B. So the diagonal can be simply seen as, or this angle bisector will act as diagonal. In a rhombus, diagonals are angle bisectors. Right? Therefore, what we can say is that the angle bisector, or vector along angle bisector, a vector along the angle bisector will basically be the sum of, this is just one of the vectors, right? Unit vector A plus unit vector B, right? All such vectors can be represented as, some lambda times unit vector A plus unit vector B. So remember this also, whenever angle bisector is taken into account, in that case, you can just take the summation of, or the sum of, the unit vectors of the given two vectors and add or multiply it by some scalar lambda. So over here, lambda is a scalar. Anyways, so this was the basic bit, a basic theory of dot product. Let's see a few questions which have been, appearing in JEE. One question which I wanted to take in the very beginning is the question from JEE Advanced 2017, last year, in fact. Let's read the question. The question says, let O be the origin and let PQR be an arbitrary triangle. The point S is such that these two relationships hold true. Then the triangle PQR has S as its what? Now, if you see over here, O is the origin, hence OP, OQ, OR, OS, these are all position vectors. I hope all of us already know what are position vectors. So we would say that there is a kind of triangle PQR, and we know their position vectors, PQR. The position vector of this is vector P, vector Q, which is OQ, this is vector R. And because S acts as any one of these options, so S is basically a point which is associated with these vertices. So it's sort of connected with them. We'll say this is vector S. Let's connect them. Okay. Hopefully everyone is clear with what the question is trying to portray. The question is asking what this point S is basically. This point S is basically what? Is it the centroid, orthocenter, incenter, or circumcenter? So let's see what is being given to us. The given bit is vector P. This is vector P dot vector Q. Vector P dot vector Q plus vector R dot vector S is equal to R dot P plus Q dot S. Okay. So if I just shuffle or bring everything to the left-hand side, I can very easily say that over here, Q can be taken as a kind of common, no? So we can get P minus S dot Q, P minus S dot Q. Then from here, if I take R common, I'll get S minus P. If I take negative R common, negative R, I'll get P minus S again. Obviously, this is the dot product. You're not multiplying. Is equal to 0, which can be rewritten as P minus S dot Q minus R. And we know P minus S, position vector of P minus position vector of S is vector SP, and this is vector RQ. These two dot product of these two vectors is equal to 0 implies what? These two vectors are perpendicular to each other. SP is perpendicular to RQ. From the first one, we are getting SP perpendicular to RQ. Similarly, if you see the second one, this is QR and PS, vector Q dot vector R, vector P dot vector S. So if you're going to solve this, let's in fact solve it. So what will we have on the left hand side? We have P dot Q, change the color of the pen, P dot Q plus R dot S. I hope most of us will be able to analyze. And if you would have analyzed, you would have gotten the result as well, that what the answer to this question will be. See, if I take this on the other side and take q common, I'll get p minus r, vector q. And from here, if I take s common, in fact, negative s common, no, sorry. So I'll take r common over here rather than taking q common, so that I can take p common over here. So p common will get q minus s. And over here, if I take negative r common, so we'll get q minus s, right? And in this case, we'll say vector p minus vector r dot q minus s is equal to 0, which implies vector rp dot sq is equal to 0, which also means that sq is perpendicular to rp. Sq is perpendicular to rp. Now see over here, the first one says sp is perpendicular to rq. This line is perpendicular, this vector is perpendicular, right? And the second thing says sq is perpendicular to pr. Okay, this is also perpendicular. Implies both are altitudes. If both are altitudes, the point of intersection of the altitude is called as what? Orthocenter. So the answer to the question turns out to be B, which is orthocenter. So it is such a simple question. It just requires a bit of manipulation. After that, you can conclude very easily that it is basically referring to the orthocenter. Most likely everyone is clear with it. Let's see one more question. This came in year 2011. This is a question on projection. Projection. We have done the basic, the concept of projection, which is a very simple thing. Projection of A on B is A dot B cap. So over here, A, B, and C are the three vectors given to us. Very important statement. A vector B in the plane of A and B. Now, whenever you get this statement, a vector A or a vector V in the plane of A and B, in this case, always you can assume vector B as A plus some scalar times B, because all the three are coplanar vectors. V, A, and B, they lie in the same plane. So basically, they will be linearly dependent on each other. So we can say V can be expressed as the sum of A and B, considering some association of scalar in between them, which is lambda in this case. So this is kind of simple. So we can assume that V is something like this. Therefore, we can say vector V we'll place the value of A over here and B over here. So we'll get 1 plus lambda. 1 plus lambda I. We'll collect all the I as all the j's. Over here, 1 minus lambda plus 1 minus lambda times j. This is vector V. And this plus this, so which is 1 plus lambda times k. K cap, this is vector V. Now the question further says, a vector B, which lies in the plane of A and B, whose projection on C is this, right? So V's projection of C, V's projection on C is V dot C cap, V dot C cap. So we can figure out C cap very easily. What is C cap? We already know vector V. What is C cap? A vector divided by its magnitude. Simple. And thereafter, we just need to take the dot product between the two. So what will we get? V dot C. This is being given as the projection has been given as 1 by 3. Whose projection on C is 1 upon root 3. So V dot C cap is 1 by root 3. So V dot C will basically be equal to what? 1 plus lambda plus 1 minus lambda plus 1 plus lambda divided by root 3. This is given to us as 1 by root 3. And most important thing, do not forget to put a mod over here, because the projection is always positive. Projection is always a distance, so it's better to put a mod out here, right? So now it's kind of simple. We will say basically this turns out this and this gets cancelled out. Oops, wait a minute. This is 1 minus lambda. Wait a minute. 1 plus. So this minus. Okay. So minus will come over here. Multiplying this by taking the dot between the two. So this and this both will be negatives. Taking the dot between the two, this into this is 1 plus lambda. This into this is minus times 1 minus lambda. This into this is negative times 1 plus lambda. So 1 plus lambda gets cancelled out. Basically what you have is over here lambda minus 1 is equal to 1, which implies lambda minus 1 is equal to 1, opening up the mod, or lambda minus 1 is equal to minus 1. So this gives me lambda is equal to 2, or lambda turns out to be equal to 0. Lambda when is equal to 0, it gives me v equal to a, which is kind of not very important. So lambda is equal to 2 will be the correct answer for the question. If I place lambda is equal to 2 over here, I'll get my answer. So this is 3 minus 1, 3. C turns out to be the answer to the question, which is absolutely correct. Okay, you can see a very similar question over here. Very similar question over here, isn't it? A, B, C being given, vector coplanar along C. This came in year 2006. I hope you can do this question. You can try it at your place again. You will get a very similar result. Exactly same question, which repeated in 2011, right? Only the vectors are different. Okay. Okay, Roshan, we'll sort of increase the speed in a moment. So similarly, if I talk about vector product, we all know what vector product is. I'll just quickly go through the summary of it. So we know A cross B is AB sine theta, theta is the angle between them, times the vector n, which is the perpendicular vector to these two planes, which is very easy to determine. If this is equal to 0, it implies vector A is parallel to vector B. Next thing, I must talk about the geometry, wherein people face problem. So what are the results in geometry? Number one result is the vector product. This is a unit vector perpendicular to plane of A and B. Plane of A and B. Okay. So A cross B, what this basically is, this is the area of, this depicts the area of parallelogram. If I take the magnitude of it, it depicts the area of the parallelogram where A and B are the adjacent sides. Vector A and vector B are the adjacent sides, in that case, area of the parallelogram, right? Next bit, if I talk about a triangle ABC with position vectors as A, B, and C, with position vectors as A, B, and C, then the area of triangle, can anyone tell me? Area of triangle ABC, that is half of A cross B plus B cross C. You need to remember these, C cross A, right? It's half of this, right? I've already explained, Akshay. If these are the two vectors, any vector that is perpendicular to the plane over here, this entire plane, this is n cap. Yeah. Okay, area of triangle ABC is half times this. If the points are collinear, what do you think the area of the triangle be? If the points are collinear, what do you think? The area of the triangle, oh no, collinear points. Very nice. Then the area of the triangle is 0, which implies this is also a good result to remember. A cross B plus B cross C plus C cross A must be equal to 0, right? This is the vector form of the area usual. Obviously, area of the triangle is half into base into height. All right. Last bit, which you should remember over here, that area of any quadrilateral, last bit, area of a quadrilateral with diagonal vectors. Area of the triangle with the diagonal vectors D1 and D2. If D1 and D2 are the diagonal vectors, then area of quadrilateral is, I must write it over here, area of the quadrilateral with diagonal vectors D1, D2 is half D1 cross D2. Half D1 cross D2, which is also sort of the area of rhombus. The formula to calculate area of rhombus, half into product of diagonals. So D1 cross D2 is not the multiplication of the vectors, but the cross product of two vectors. Okay, this was a basic summary on vector product. Let's pick a few questions, have a discussion on them, and then we'll see what else we can do. Okay, so over here, it says if the vectors this form the sides of BC, CA, and AB respectively of the triangle this, then which of the following is true? It's a very interesting question. See, and there were two questions based on the same concept. I'll show you the next question as well. See, if there is a triangle, it's based on addition as well as vector addition as well as cross product. So this is vector A, this is vector B, this is vector C. Okay. Now over here, I hope all of us can realize that vector A plus vector B plus vector C must be equal to 0 because they are lying in the same direction. So this must be equal to 0. If I take the cross product with A, if I take the cross product with A, so over here, vector A cross vector A will be 0 because both are parallel. Parallel vectors taken cross makes it 0. What else we get? A cross B plus A cross C is equal to 0, which can be rewritten as A cross B is equal to negative A cross C. In fact, I would suggest that you should remember the result, which I'll be deriving after some time. Or this over here, negative A cross C is C cross A. We all know about it. So we got one result that A cross B is equal to C cross A. Similarly, over here, if I take the cross product with B, if I take the cross product with B, what result will I get? B cross A, B cross B will be 0. Over here, B cross C is equal to 0. Now, similarly, I can say this A cross B will be equal to B cross C. If I take this on the other side, it will be negative B cross A. If I change the sign, the positions of A and B will change. So A cross B is equal to B cross C. From these two, if I combine, I'll get the result which I actually was looking forward for, that A cross B will be equal to B cross C, will also be equal to C cross A. So in a triangle with vertices, with sides vector A, vector B, vector C, this thing will always be equal, whatever may be the type of triangle you have. The correct answer for the question is B. Most likely everyone is clear with it. See, a similar question. So this appeared in 2000 of 2 marks. In 2007, it appeared for 3 marks. What was the question? The question was, A, B, C, the unit vectors such that A plus B plus C is equal to 0 already given to us. So from here, you sort of need to form an analogy that this is basically referring to a triangle A, B, C, wherein this vector is A, this vector is B. Getting the point? This vector is C. So from here, you already know that these three are equal. It's being given equal over here, equal over here. This is a different bit. So at least these two things could be checked. These two things could be checked. So you just need to check whether this is equal to 0 or not equal to 0. What is equal to 0? A cross B or B cross C or C cross D. What you know is all are unit vectors. If all are unit vectors, what type of triangle will it be? It will be a equilateral triangle because all the sides are equal. Okay. Equilateral triangle implies what is the angle? 60 degrees. Very nice. So we know the angles, we can find out the cross product. All right. So that will be A cross B is basically what? AB sine 60 degree. Unit vector will just give me the direction. Just give me the direction. It will be the same. So I'm not applying the unit vector over here. This is 1, this is 1, and this is what? Root 3 by 2. So root 3 by 2. So basically over here, we're going to have this result not equal to 0. The correct answer for the question will be B. I hope this is clear to all of us, right? Absolutely. Okay, most likely. Okay, now this is also a very simple question. This was a question in JEE Advanced 2017. It is a paragraph-based question. So let O be the origin, and these be 3 unit vectors in the direction of OR, PR, and RP and PQ, right, respectively of the triangle this. If the triangle varies, the minimum value of this is what? So basically, there is a triangle PQR, PQR, QR varies as OX. This is QR. Then RP varies as OX, and OZ or PQ. Sorry, PQ is OZ. Right. So if you want to mention, this is OX, OY, and OZ. If you want to see it that way. Right, so this is how you can plot it. You need to figure out the minimum value of this. Very, very simple question. See, cos p plus q can be written as cos of pi minus r. Cos q plus r can be written as pi minus p. And this can be written as cos pi minus q, which is negative of cos r, cos p, cos q. You need to figure out the minimum value of it. Minimum value of it. Minimum value of this will be when this is maximum, because a negative bit is negative number is being incorporated. And cos A plus cos B plus cos C for a triangle ABC will be maximum only when the triangle is equilateral triangle. So maximum implies equilateral triangle. This is also a result from properties of triangle. You can get it. And as soon as it turns out to be equilateral triangle, we can see that this is 60 degrees, 60 degrees, 60 degrees, 1 by 2, 1 by 2, 1 by 2, which is 3 by 2. So this turns out to be the answer to the question. I hope this is clear to all of us. So the correct answer to the question is A, which is negative 3 by 2. Fine enough. That's it. That's all what we had. There is one more question associated with it, the same advanced one. So you can do this. It's a very, very simple question. You can try this question as your homework. All right. That's all what we had for the day. Take care. I'll again say that the vector is an easy topic. So put in your energy, try to understand and learn the concepts, at least the formulas. You will be able to score very good scores in your JEE mains and advanced. Till then, good night. Have fun. Take care. Bye, guys. See ya.